Introducing ApplyAble, a game-changing MVP project that aims to transform the way job seekers and employers connect. ApplyAble is a two-sided job search marketplace designed to simplify and streamline the job search process for both small business owners and employees. With its intuitive interface, direct communication features, and intelligent matching algorithm, ApplyAble empowers users to effortlessly navigate the job market, find the best talent, and discover the perfect job opportunities. This MVP project is set to revolutionize the job search experience, offering a glimpse into the future of efficient and effective job matching. The application covers most of its functional requirements. User registration. Users are able to register on the platform as either job seekers or employers. The registration process collects necessary information such as name, email address, and password. Profile creation. Users are able to create and manage their profiles. Job seekers can provide details such as their skills, qualifications, work experience, and preferences. Employers can enter information about their company, job requirements, and preferences. Engaging interface. The platform has an engaging interface similar to popular apps, where job seekers can view job listings and like to express interest or cancel to reject. Employers are able to view profiles of job seekers and swipe right to express interest or cancel to reject in a similar fashion. Matching feature. The platform provides functionality to match a job seeker and an employer should both the users choose one another depending on their profile and preferences. Chat interface. Once a match is made, the platform provides a chat interface that allows job seekers and business owners to communicate with each other. The chat interface supports text messaging and possibly other media formats. This feature has not been extensively covered in the project MVP. However, the back-end functionality for this feature has been laid out. Availability. The platform has a high availability. It is accessible to users at all times, with average downtime for maintenance and updates being less than 10 minutes. This is because of automated deployment of the project using Terraform. Interoperability. The internal components of the platform are able to share information and communicate effectively. This is because of the monolithic architecture of the system, combined with a model view controller pattern, which allows streamlined sharing of data. Scalability. The platform is able to handle a large number of users. It is scalable to at least 1,000 users initially and has the capability to scale further as the user base grows in a short amount of time. This is due to AWS ECS clusters that can be horizontally and vertically scaled in a matter of minutes and with trivial changes in code. Reliability. The subsystems of the platform are reliable and fault-tolerant even after having a monolithic codebase. Errors in one API endpoint do not stop the functionality provided by another. Usability. The platform has user-friendly and intuitive interface. It is easy for both job seekers and business owners to navigate, create profiles, search for jobs, and communicate with each other. The platform is designed to minimize the effort required from users in performing tasks. Maintainability. The platform is designed and implemented in a way that facilitates easy maintenance and updates. This is a result of using open API specifications and generators to generate the core stub of the model view controller pattern in the backend. The backend API is modular, well-documented, and adheres to best practices to ensure maintainability. Adding extra models doesn't require a huge change in the codebase, nor does it affect existing API endpoints. ApplyAble is meticulously crafted utilizing a combination of architectural patterns and cutting-edge technologies to ensure optimal efficiency and functionality. Our app's architecture employs a monolithic architecture approach, complemented by a model view controller (MVC) pattern based on an open API specification. Furthermore, we leverage a client library to maintain consistency across our front-end code bases and to provide interoperability for any upcoming additions to the front-end. The monolithic architecture of ApplyAble consolidates all features and components into a single deployable unit, simplifying both development and deployment processes. This architecture streamlines the overall development workflow, allowing for seamless integration and management of the application's functionalities. Within the backend of ApplyAble, we have incorporated the model view controller pattern. The model encompasses the entities, attributes, and relationships essential to the application's functioning. It embodies the business logic and data access methods, interacting with the database, handling user events, and validating requests. The view layer handles presentation and UI component generation, rendering data provided by the controller to the user. The controller acts as an intermediary, facilitating communication between the model and view, executing business logic, and delivering results to the view. ApplyAble also implements a thin view layer architecture, where the view is primarily responsible for rendering components and handling user interactions, while the model and controller handle the bulk of the business logic. This design enables greater flexibility and interoperability, allowing for future integration with diverse platforms without necessitating extensive modifications to the view layer. To ensure efficient API development and documentation, ApplyAble utilizes the Open API specification. This API-first approach enables comprehensive documentation of API endpoints and facilitates the generation of corresponding request and response structures. By employing the Open API specification, we enhance development speed, reduce potential manual errors, and foster better collaboration among team members. Additionally, ApplyAble incorporates a client library to maintain consistency across different view layers, such as web apps and mobile apps. This ensures a unified code base, allowing seamless access to the backend functionalities regardless of the specific view layer, enhancing cross-platform compatibility and eliminating discrepancies. Through the strategic application of architectural patterns and the utilization of industry-leading technologies, ApplyAble establishes a robust foundation for its functionality, efficiency, and future scalability. Building ApplyAble has been an interesting journey, providing the team with amazing insights and knowledge. We learned a lot, and we appreciate the challenges that not only prepared us for the industry, but also gave us valuable technical knowledge. At the project's inception, we underestimated its magnitude, and the project's objectives were somewhat ambiguous. Consequently, we faced a significantly heavier workload than initially anticipated. To address this challenge, we sought innovative techniques to automate various aspects of our workflow. Contrary to our initial plan of adopting a microservices architecture, we opted to maintain a monolithic codebase. This decision proved advantageous for our small team, enabling parallel work on different tasks without sacrificing coherence or encountering misunderstandings between codebases. To reduce our workload even further, we devised a system that eliminates the need for manual coding of models. Essentially, by modifying the OpenAPI specification and utilizing automated generators, a significant portion of the backend functionality could be seamlessly managed. We decided to extend the base class generated by OpenAPI Generator achieve database persistence. By combining this technique with dynamic mapping of model classes to database tables, we approached the tests with a somewhat less stringent attitude, postponing them until later stages of development. Ideally, we would have preferred to prioritize testing prior to development. Unfortunately, this approach resulted in discrepancies within the API, leading to confusion, difficult-to-tackle errors, and development delays. Despite the insufficient testing, the utilization of the OpenAPI specification and its generated code greatly contributed to maintaining consistency within our codebase. Each time a model required modification, we ensured that all related models were updated accordingly. This approach, combined with the adoption of a model view controller (MVC) methodology and iterative development, proved highly beneficial. Initially, we began with a minimal number of models, progressively evolving them as the need arose. For instance, the user model was implemented after the employer and job seeker models. Remarkably, these changes did not impede our progress or disrupt our codebase. Our project encompassed multiple facets, and instead of distributing the workload among different teams, we attempted to handle each aspect individually. Although this approach is typically suitable for larger teams, it proved challenging for us. Notably, two crucial tasks, testing and API endpoints, could not be delivered on time, which further impeded deployment and front-end development. Had multiple team members been assigned to these tasks, such bottlenecks could have been mitigated. Consequently, some team members had to assume multiple responsibilities to compensate for these delays. In conclusion, the project was successfully deployed and tested, and we managed to cover most of our intended functionality, only compromising on relatively trivial features such as authentication, lesser-used API routes, and features that can be easily built in subsequent sprints.